Okay, what about voltage? Is there some analogy, some generalization we can use to think? The answer is yes. So this diagram here is a mountain, and the start is where we're going to begin a hike. And bear with me for a minute. So let's start this hike, and we're going to go up this trail, go back to the start. Okay, so this is the route we took. We went from the start over to point A, over to point B, and then back to the start will also be our finish. Okay, so in this case, think how much did our height change throughout the entire hike? Well, initially we went up to point A, so that would have been positive. And then we went down to point B, and point B is less than the start, so that would be negative. And then we went back to the start. So I think if we went around the entire loop from start back to finish, I think the total height change around that loop would be 0. So let me write that down. Total change in height. As long as we start and stop at the same spot. So let's say start to start would equal 0. Okay? Now, the height, and here's where we have to be a little bit clever. The height of this mountain, another way to think of the height is a quantity that indicates how much gravitational potential energy we have per amount of mass compared to the start. So at point A, we have more gravitational potential energy compared to the start. At point B, we have less. So our height is proportional to that gravitational potential energy per amount of mass. And if you like a formula from Physics 1, you could recall gravitational potential energy was equal to mg times h, as long as you're near the surface of the Earth. So that height is gravitational potential energy per mass. Now, of course, there is that other little like constant g in there, but that's not really changing anything here. So since the height is equal to the gravitational potential energy per mass, and the total change in height from point S to S would be 0, then we could say that the total change in gravitational potential energy per mass from S to S is equal to 0. Okay, and then what if we had a word for this? What if we invented a word for gravitational potential energy per mass? And what if we called that voltage or something like that? Then what we would say is the total amount of voltage from start to finish on this hike would be 0. In fact, what would happen if you started at point A? So if I started at point A instead of the actual start, and I went around a loop that ended at point A and added up all of the voltage, what would I get? Well, initially I'd go down, so that would be negative voltage. Go back up to start finish, that would be positive. Then from start finish to point A, that would be positive. And since the voltage is the gravitational potential energy per mass, which is proportional to the height, we already know that the total change in height around that loop would be 0. So therefore the sum of all the voltage around this loop would be 0. Okay, so that's the initial idea. How does this connect to circuits? Well, voltage is electric potential energy per amount of charge. So instead of being gravitational potential energy per mass, it's electric potential energy per charge. If you have a circuit and you start somewhere on the circuit, say I start at point C and I go to point B, could the voltage change? Sure. That would be like on our mountain starting at point A and traveling over to point B. Can the height change? Sure. But what if you started at point C and traveled to point A and then back to point C? If I start and end at point C, how much can the electric potential energy per charge have changed? The analogy here is good. If I start at point C and come back to point C, the total amount of voltage would have to be zero. So the sum of all the voltage differences from C to B to A and back to C would have to be zero. So we could write that as the sum of all the voltages around any loop. But I have to start and stop at the same spot, would be equal to zero.